We've been concentrating on converting pictorial, or three-dimensional views, into orthogonal, which are useful for accurate dimensioning and true perspective. Orthogonal drawings are used to construct a workpiece. But sometimes they're not the easiest way to visualise the object, like this for example. But if you've seen the object, then the orthogonal drawings are much easier to interpret. But when you've got to manufacture an object you've never seen, converting the orthogonal drawings into some form of pictorial representation is often a good idea. For the same reason, pictorial representations are often used in service manuals or catalogues because of their clear presentation of assembly. But as you'd expect, there's more than one type of pictorial drawing. Two in fact, isometric and oblique. Isometric drawings are based on the edge, while an oblique drawing is based on one of the faces. If we convert this oblique cube to a line drawing, then you can see that no side is truly square. However, square to the viewing position, this face is truly square. Note that the front-back measurements are halved. This is known as the cabinet or cavalier method, depending on which manual you're using. When we talk about oblique, you can assume all the front to back dimensions are half their true value. But back to isometric drawing. Isometric drawings always start by drawing a horizontal line with a vertical line perpendicular to it. Then draw in your two 30-degree lines. And here's a trick for you. If you're using graph paper, then 30 degrees can be found by going 2 squares out and only 1 square up. If you're using plain paper, construct 30-degree angles using compass or dividers. It'll be covered later in the module, so for now, just use graph paper. Once we've got this basic isometric starting shape, we're going to draw a box that will completely enclose the object. So extend the 3 key guidelines out beyond the longest dimension needed. Keep these lines light since they're construction lines and are going to be erased later. Measure or transfer the measurements with a pair of dividers for the longest dimensions in each direction. From each of these overall dimensions, draw in vertical lines. Still drawing in light lines as construction lines. There will be more on different line types later. Complete the box by projecting lines parallel to each of the guidelines. I'm sure you've got the hang of that by now. Then plot the specific dimensions on the faces of the box. These measurements are easy to get straight off the orthogonal drawing. Then join the dots. Draw in a light outline of the object. Then all we've got to do is darken in the outline and remove the construction lines. And there's the finished drawing. The practice examples you'll start with have the diagonals already printed for you, so that'll make it a lot easier to begin with. Like isometric drawings, oblique drawing has a standard start. But for oblique drawings, it's a rectangle. the overall height and length of the side that will be drawn parallel to the page. Obviously you'll choose the side that best reveals the true shape of the object, where there's the most detail. We extend each of the corners of the rectangle back at 45 degrees. They can be left or right of the rectangle, depending which side will show the most detail. Of course, I don't need to remind you that on graph paper, 45 degrees is from one corner of the square to the diagonally opposite corner. Mark in half the width of the subject on each 45-degree line and draw in the guide box at the back. Not that you need to see me draw in every little detail. Now plot the true shape on each of the faces. Here's where you'll discover one of the main advantages of oblique drawings. When there's a curve in the object, it's easy to draw it on the true front face and project it back. Drawing circles and curves in isometric drawing is really difficult because you've got to work out what they look like in perspective. With an oblique drawing, you just draw them on the front face and project it back. Darken the outline of the object and remove the construction lines. You don't need me to show you how to do any more of that. Once again, there's the pictorial view of the object. Notice that the width still looks in proportion even though we halve those dimensions. That's all from me for a while. It's up to you to practice these techniques. They're all explained in your student workbook and I'm sure your teacher's there to help you. You may even be able to refer back to this video if the equipment's handy. The important thing to remember is to practice and keep practicing until these techniques are second nature.